Let's look at some of the other organ systems which are developing in the body. Looking back at the skin, remember that it has two layers, an epidermis and a dermis. Well, when you look at these embryonic germ layers, the epi, the outer layer of the skin, develops from the ectoderm, which is the outer layer, and the dermis is derived from the mesoderm and some neural crest cells in the face too. The skeleton will largely develop from the mesoderm, also some neural crest cells. Muscle develops from myoblasts. That literally means muscle building cells. We only have these muscle building cells during embryonic development. That's why later in life we can't replace muscle. Somebody has a heart attack and they lose some of that muscle, well, it's never coming back. And then the nervous system is derived from the neural tube, which we saw previously. Looking at some of the other organ systems, look at special senses like the olfactory bulb and nerve. This will develop from the telencephalon, part of the embryonic brain. The eyes from the diencephalon, and the ears from the ectodermal placodes. Just pinch off from these regions. Looking at others like the endocrine system, the posterior pituitary comes from the floor of the diencephalon, part of the embryonic brain. Anterior pituitary from epithelial cells in the roof of the oral cavity. The thyroid gland from the floor of the pharynx, which remember again is your throat. Parathyroid glands from other pharyngeal pouches. The adrenal medulla. Remember how that'll later form the sympathetic division and part of the sympathetic nervous system. These develop from neural crest cells. The adrenal cortex, which is very different from the medulla, is derived from the mesoderm, and the pancreas from part of the duodenum. Looking at our circulation and specifically the heart starts off as two parallel tubes. It's like two tiny little blood vessels, and they'll fuse together. As they fuse, they'll start to enlarge and develop into the four different chambers. But they also flip and twist 180 degrees. So our atria actually started off inferior on the bottom and the ventricles on top, but due to this 180-degree twisting, that tends to put the atria on top, the ventricles on bottom, just as we always see it in any of our pictures or models you may have looked at before. Also, at the same time as this heart is developing, all these structures, valves, and chambers develop, so do the walls that separate the atria and the ventricles. And if you look at that upper inner atrial septum that separates the two halves of the atria, right and left atrium, there'll be two structures forming, septum primum and secundum. One of them actually has a hole in the top of it, one in the bottom, so blood can actually mix between the right and left side of the heart back before we're born. But when we take our first breath, pressure changes will force these two pieces of tissue together. And since one had a hole in the top, one in the bottom, if they fuse together, there'll no longer be a connection between the right and left atria. So that'll stop the blood flow from mixing between the right and left side, which is what we definitely need to see happen after we're born. Looking at the respiratory system, the lungs just develop from what looks like a bud growing outward. You see this just anterior to the digestive tract as it's developing. So this little bud will grow outward and split and continue to do so until it forms the 23 or so branches of the tracheal bronchial tree. The development of the respiratory system doesn't finish until after an individual is born. Makes sense since you're not really using your lungs to move air in and out of them before you're born, but of course you have to as soon as you are. Looking at the urinary system, the kidneys develop from the mesoderm, and that's the middle layer of those germ layers. It's located between the somites and the lateral part of the embryo. Reproductive system, take the male and female gonads. They'll first appear as gonadal ridges. And remember, females, as far as the 23rd pair of chromosomes, are XX and males XY. So in the absence of a Y chromosome, the female reproductive system will develop. In the presence of a Y, a male will develop. And at this time, we'll be able to see primordial germ cells. These will later become the reproductive cells of the body, oocytes and sperm cells. The fetus, somewhere around day 60, becomes an embryo. Looking at this fetal period, you can see the appearance of other structures like lanugo, very fine, soft, unpigmented hairs. Those will later develop into the adult hairs. And this vernix caseosa, which is a waxy coating around the baby, helps to protect it from the basic fluid, which you'll be surrounded by inside of the uterus. Looking at parturition, it's just a fancy way of saying childbirth and delivery here. It's believed there are many things involved, right? Now, oxytocin is the primary chemical signal. But looking at some of these other, like estrogen, it's believed that estrogen overcomes the inhibiting influence of progesterone about this time. The stress of the baby running out of room, right? It's run out of growing room, cause the baby will release ACTH. It's thought the stretching of the uterus added to all this causes the posterior pituitary to release oxytocin. Again, oxytocin is the primary chemical signal when it comes to parturition. Opens up ligand-gated calcium channels on that smooth muscle of the uterus, causes depolarization and muscle contraction. Looking at labor, there's 3 different stages. Looking at the first stage, this occurs with the regular onset of uterine contractions, and the cervix will start to dilate at this time. Baby's head acts as a wedge against that cervix and helps to force it open. Second stage occurs from maximum cervical dilation till the baby exits the vagina. And then the third stage is characterized by the expulsion of the placenta from the uterus.